Greetings, just a short video to show you how to do calculations in the chi-square distribution using the R cadre of density functions. So let's take a look at something possibly that may seem somewhat familiar. Let's say you had a chi-squared test statistic that came out to say 2.32 and your degrees of freedom were equal to 2. And so in this distribution, which just happens to be kind of a sample one here, 2.32, let's see, that's about 2.5 right there. So that'll be, say about there-ish, okay? So this corresponding red zone here would be the area to the right of 2.32. Now, why would I want to know the area to the right? Well, if I'm doing a hypothesis test in a chi-square distribution, it's always going to be to the right because chi-squared is always a positive value, and when we do the calculation of the p-value, it's always going to be a right-tailed test, okay? So we want to know what that corresponding p-value would be for that particular chi-squared. Notice like this keeps going off to positive infinity in that way. Now the problem be that when you use R, and for a matter of fact, if you use pretty much any software package that does probability calculations, it almost is a certainty that it's going to not sum from the point you give it to the right, but instead it's going to sum from the point you give it to the left. In other words, it's going to give you the lower part or the lower tail. So that would be a lower tailed calculation, and that is very common. I mean, even probably almost all the printed tables give you the lower tail also. Not exclusively, but it's pretty common that that's the way they're going to do it. Kind of standardized that just give them the area down the lower tail and life will be good. All right, so how do we get chi-squared out of R? Well, we're going to use p chi-squared. And you're going to give it the value you want, which in our case is 2.32. And you're going to give it the degrees of freedom, which is 2. But now you have to add in one additional thing. You got to tell it lower tail is false. So lower dot tail equals capital F for false. And if you do that, it will give you the upper tail. Now, of course, you could just go 1 minus p chi, right? P chi squared, and that would work also. But you got to recognize why you're doing that, okay? So in other words, these two would be equal to each other. You'll get the same number either way. So let's go over into R and let's go see if that works, okay? So we'll put in P chi, oh look at that, and it gives me autocomplete because I put an R in there and I didn't want an R, it's just SQ. And so I'm going to go put in 2.32, comma 2, comma lower dot tail equals false. And what did I do wrong there? Unexpected symbol in, I wish I could. I'm going to learn to type someday, and that's going to make my life so much better. There we go. Okay. And now if you go back and you take a look at problem 6.41, which is the textbook sales distribution one, and where they did a chi-squared goodness of fit test, you'll see that they came out with this almost pretty much exact same number there for their p-value using the chi-square test. So hopefully that helps. If you need any further help with this stuff, don't be shy about asking.